You guys will need to, actually, I suspect if you chat something, I'll be able to see it, or you can unmute and talk to me. All right, so the goal of this lab is to find the specific heat capacity of a couple of these little metal cylinders. And the reason we're trying to find their specific heat capacities is so that hopefully we can figure out what they're actually made of. So to do that, we're gonna get them hot. I have a pot of boiling water over here. Look, you can see the steam, isn't that nice? So we'll put the metal cylinders in there for a couple of minutes, and that should be long enough that they'll reach 100 degrees. And then we're gonna transfer them into a cup of cold water, and we'll see what the final temperature is. So the data that we're gonna need is basically mass data and temperature data. So I have a trusty thermometer, and I also have an electronic balance that I grabbed from the lab. The first data point you're gonna need is the mass of the empty cup. I already got this mass this morning when it was dry. So the mass of the empty cup was 8.91 grams to start with. The next thing we're gonna need is to decide which metal to start with. I'm gonna say this one. It's sort of like a yellowish metal as opposed to the gray metal that we'll do next. It's also the slightly taller of the two cylinders. So we're gonna need the mass of this piece of metal. So I'm gonna put it on the scale. And it has a mass of 70.54 grams. All right, as a reminder, as we're going through the lab, the two things you want to be sure that you're doing are writing down the data and also recording the procedure as I do it. Now, before I start doing any kind of real lab, especially anything with heat, what should I be wearing? I'm going to pretend like you've all shouted goggles. I should be wearing my goggles. So here we go. You all don't have to wear goggles. I assume that you're safe where you are at home. All right. So I need to put my metal cylinder into my boiling water without hurting myself. So I have a little string with a loop at the bottom. I'm going to lower it into the pot of water, and I'm going to clamp it up here so that the string doesn't fall into the water. All right. And we're going to leave that there in the boiling water while we do the rest of our steps. So we have our cup here, but right now our cup is empty. I've got a Kane's cup full of room temperature water. Sometimes we have to make do with the supplies that we have. We want to know what mass of water we have, but we can't mass water by itself. We have to mass water in a container. That's why it's going to be important later that we know what the mass of the empty cup was. I had too much water in there at first, that's why I'm pouring a little bit of it out. There we go. So the mass of the cup plus the water is 143.33 grams. 143.33 grams. All right, now I need to know what my initial temperature for the water is. So I'll kind of swirl the thermometer around in the liquid a little bit and let it sit for a minute or so. Make sure that it's come to equilibrium. The temperature of the water should be the same as the temperature of the room because that cup of water has been sitting out all day. So I don't expect it to change very much, but just in case, I want to be sure to give it plenty of time. So basically I'm just going to watch and make sure that the number's not changing. And it's not. 21.7 degrees is where we're starting. All right, 21.7 degrees Celsius. All right. And in that time, our metal should have come to equilibrium. It won't take long for a piece of metal in a pot of boiling water to be at the same temperature as the boiling water. So I'm going to transfer this as quickly as I can do it and safely from the pot into the cup. And now we're going to swirl this guy to make sure that all of the heat that was in the metal gets transferred to the water. So obviously we expect the temperature of the water to go up. And we're going to keep swirling with the thermometer and swirling the water around the metal. It's generally not the best idea to use a thermometer to stir something. We have stirrers that are less expensive than a thermometer. But if we're just swirling some water around in a cup, it's not too terrible a risk to take. All right, I bet that's it, but we'll give it just a few more seconds. Now the temperature has gone up, and if I wait long enough, the temperature is going to start coming back down until it reaches room temperature again. So I don't want to leave it in there forever. And that's just a smidge higher, so we're going to keep stirring. And that hasn't changed. So 25.2 degrees is our final temperature. So that tells us how much the temperature of the water went up. We know that the metal should have started at 100 and came down to 25.2. And we'll need that information to do the calculations for the lab. All right, so let's reset and do a second one. Pull my little cylinder out. I'm going to toss this water because it's not room temperature anymore. I'll get more in a second. The second cylinder we're going to use is this little short gray guy. So it's not as tall as the other one, and it's like a dark silver gray as opposed to the slightly yellow metal that we had before. First things first, we need its mass. 69.59 grams. Interesting. Even though that cylinder was significantly shorter than the other one, it's almost exactly the same mass, which makes us suspect that they're not the same substance, which we already thought because they were different colors. But it also means that we're not going to be surprised if later we find that they have different specific heat capacities. All right, got to get our metal in to our boiling water. I'm doing lab.
Oh, are you recording?
Yes. Actually, also Lexi and Manisha are watching, so you can say hi to them if you want to. Guest appearance by Andrew. All right, so our second cylinder is in the boiling water coming up to temperature. We're going to get the mass of our cold water. In the cup. So this time in the cup, we have 142.65 grams. 142.65 grams is the cup and the water together. We need to figure out what temperature we're starting at. So we're going to stir with the thermometer here for a minute. Swirl it around. And we're expecting that this temperature is likely to be the same as it was before. Although honestly, I think this is really 21.8. I think this temperature is just a tiny bit warmer. Maybe because the cup got a little bit warmer. All right. Our metal cylinder should have reached the temperature of the boiling water. So we're ready for the transfer. Again, we're going to do it as quickly as we can. As soon as the cylinder comes out of the boiling water, its temperature is going to start dropping, and it's going to drop pretty quickly, which is why I want to do that transfer just as fast as we can. All right, so I'm swirling the water around my metal cylinder, using my thermometer to swirl the water. All right, so the mass of this metal was almost the same as the first one. The amount of water we had to start with was almost the same as the first time, and the initial temperature was almost the same as the first time. But we're finding that the temperature is not increasing by nearly as much this time. It's looking like about 23.5, but let's give it just a minute more, just in case it's still going up. Yep, 23.5 it is. so what you're going to need to do is take this data and follow the instructions in the lab handout. What that's going to let you do is calculate the specific heat capacity of the two different metal cylinders. And then I want you to find a table of specific heat capacities somewhere online. Hello, Mr. Allen. Find a table of specific heat capacities of known metals online and see if you can make a prediction about what metals these cylinders might be made of.